All right, so the first thing we want to do is take our inequality and set it equal to 0. I say set equal, it's still going to be an inequality, but we want 0 over on the right-hand side. And in step 2, we want to find the zeros. That's exactly what we did on our last test when we solved those quadratic equations. So step 1 and 2, we've already done that. We just have to do it again, and then we're going to add a little bit more to it. We're going to label the zeros on a number line. So we're going to find the zeros, we're going to put them on a number line, we're going to use closed dots and open dots. There's actually a typo on here, so if you can fix that, that first closed dot should be open dot. We want to use an open dot for less than or greater than, and closed dots for less than or equal to, or greater than or equal to. We're going to create a sign chart on our number line. We're going to test points in each interval, and using the factored form is easiest, especially without a calculator. And then we're going to use the sign chart to determine all of the values that made the inequality true. And then we're going to write our answer like we did just a second ago with inequality in interval notation. So number 1, x squared plus 4x minus 12 is greater than or equal to 0. We're looking at this quadratic function, and we want to know, when is this quadratic function going to be greater than or equal to 0? And we're talking about the y value in this case. When is the y value going to be greater than or equal to 0? We could guess and check, plug in a bunch of numbers. Oh, well, this number works, and this number works, and that number didn't work, and this number didn't work. And we're just kind of spinning our wheels. So what we need to do first is find the zeros. And every single problem we're going to do in this part of the unit can be factored. So what can we multiply to get negative 12 that adds to give us 4? Those numbers would be positive 6 and negative 2. So we get x plus 6 times x minus 2 is greater than or equal to 0. So what would x equal? What would make this inequality actually equal to 0? It would just be the solutions to the equation. So x would equal negative 6, and x would equal positive 2. X would equal negative 6, and x would equal positive 2. Not bad, right? All right, now, we're going to draw a number line. And on our number line, we're going to put negative infinity on the far left. We're going to put positive infinity on the far right. And we're going to put negative 6 and 2 somewhere in the middle. As long as they're on there, it doesn't really matter where. So what we've done now is we've broken up the number line into 3 intervals: negative infinity to negative 6, negative 6 to 2, and 2 to infinity. And we got to figure out, like, which one of those intervals is my quadratic function going to be greater than or equal to 0. And we can figure that out several ways. The one way we're going to do that is algebraically. And algebraically, we're going to pick a point in each interval, an x value. So what is an x value between negative infinity and negative 6? And the cool thing about this is it doesn't matter what point you pick. Pick any point you want. I would pick probably negative 7. And then we're going to test that point. What do you mean by test that point? I'm going to take negative 7 and I'm going to plug it in to the factored form because it's easier. And I'm going to figure out, is it positive or is it negative? Okay, does that give me a positive number or a negative number? You can use a calculator for this, but I think we could probably do it without a calculator. We end up with something like negative 7 plus 6 times negative 7 minus 2. And we don't care what the number is. All I really care is it positive or is it negative? Essentially, what the number equals, we don't really care about that part. So let's think about this idea. Negative 7 plus 6 is a negative number, and negative 7 minus 2 is also a negative number. And if we have a negative number times a negative number, what are we going to get? So every single number, it doesn't matter what number you pick, any number between negative infinity and negative 6, if you plug it back in, you will get a positive number. And that's why we call these sign charts, because we are labeling the signs that the function is going to equal on this number line. So between negative infinity and negative 6, every single y value is going to be a positive number. What about between negative 6 and 2? Pick any number you wish, as long as it's between those two numbers. I'm going to pick 0. The 0 is easy to work with, especially if we're trying to do this maybe without a calculator. You can use a calculator if you need to, by the way. What is 0 plus 6? Is that a positive number or a negative number? So we end up with a positive number times, what is 0 minus 2? A negative number. So we end up with a positive number times a negative number, which is a, so if we pick any number between -6 and 2 and plug it back in, you will get a negative number. As long as it's between -6 and 2. What about a number bigger than 2? Maybe 3, maybe 4, maybe 5, maybe 1,000. It doesn't matter what number you pick, as long as it's between 2 and infinity. So if I plugged in 3, 3 plus 6 is a positive number, and 3 minus 2 is a positive number. And a positive times a positive is always a, so every single number between 2 and infinity, when you plug that in, is going to give you a positive number. So we've created our sign chart. Now we got to figure out our answers. Are we looking for when it's positive, or are we looking for when it's negative? Well, it goes back up to this inequality symbol here. This inequality symbol here. If that says greater than or equal to 0, what are we looking for? We're looking for 0 and greater than or equal to 0 means positive or equal to 0. So where is my function? Positive. Well, it's positive from -infinity to -6 and from 2 to infinity. So this is also equal to, which means my endpoints 2 and 6 are going to get a closed dot. And now if we were to draw my solution on the number line, which part of the number line would we shade? Would we shade in the middle? No, because we don't want to know when it's negative. We want to know when it's positive. So we're going to shade outside. So we're going to go and draw our arrow to the left and draw our arrow to the right. So now we have a number line that shows me what the solutions to this inequality is. But how would I write that in inequality notation or in interval notation? Well, in inequality notation, we don't need to write infinity. We can just say, hey, x is going to be less than or equal to, because it was a closed dot. It was also equal to in the original problem, -6, or, because these don't overlap, so we're going to use the word or, x has to be greater than or equal to +2. So any number less than or equal to -6, or any number greater than or equal to 2, if I were to plug that into the original inequality, the inequality would be true. Any number between -6 and 2 would make the inequality false. So we wrote the answer in inequality notation. What would this look like in interval notation? We're going from -infinity to -6. Infinity always gets parentheses. Since -6 is included, it gets a bracket. The interval notation symbol for the word or is a big U. That literally just means or. And it's just the symbol that we use for interval notation. That means or. If you really wanted to, could you just write the word or? Sure. And then x is greater than or equal to 2. So we're going from 2 to infinity. So 2 comma infinity. Infinity always gives parentheses. 2 is included in our solution, meaning 2 will satisfy the inequality. So we use a bracket. Have to use a bracket in that case. 2 to infinity. All right, number 2. I only got 2 more examples, but it's going to take about 10 minutes per question for some reason. And it just takes a while. Not sure why. All right, number 2. Number 2 is not equal to, in quotation marks, 0. So the first thing I want to do is take that -6x and that +6, and I want to move them to the left so that the right side would be 0. And we can do that all at the same time. We can add 6x to both sides, and we can subtract 6 from both sides, The 6x and the 6's cancel out. And then we can combine whatever like terms we have on the left. So we have a negative 2x squared, we have a positive 6x, and we have a 146 minus 6, which is just 140. And that's greater than or equal to 0. That is greater than or equal to 0. Now, every problem we're going to do with inequalities, you can factor, but you could also use the quadratic formula if you're not comfortable factoring. I'm going to factor all the ones in our notes today. And if you want to see some that you want to see me work out a problem using the quadratic formula, we could do this problem with the quadratic formula. But I like to factor, so we're going to factor everything today. And if you did want to use the quadratic formula, I can show you how. If we're going to factor, we first want to check to see, can I divide by anything? And in this case, we can divide everything by 2. But we want that number in front to be positive. So instead of just dividing everything by 2, maybe we would divide everything by negative 2. Because when I divide by that negative 2, that x squared is now going to be a positive x squared. And when we're factoring, it would be much better if x squared is positive. It would be much better if x squared is positive. So negative 2x squared divided by negative 2 is going to be positive x squared. 6x divided by negative 2 is negative 3x. 140 divided by negative 2 is negative 70. And 0 divided by negative 2 is still 0. That's nice. Now we have a much easier quadratic to factor. But maybe from algebra 1, you remember doing inequalities with linear functions. And what happens to the inequality symbol when we multiply or divide by a negative? It does flip. And why does it flip? I wrote it wrong. Why does it flip? I'm going to try to explain to you why it might flip. Let's take 20 degrees and let's take negative 40 degrees. Which one of those is greater? Which one of those is warmer? The 20 is greater. But what if I were to divide both of these by negative 2? 20 divided by negative 2 is negative 10 degrees, and negative 40 divided by negative 2 is positive 20 degrees. So now which one of those is warmer? The other side. So the sign will switch. And that's always going to happen if we multiply or divide by a negative. So in this case, we divided by a negative, so we definitely need to switch those signs. So at this point, we can factor. We have x squared minus 3x minus 70 is less than or equal to 0. So what can we multiply to get negative 70? That adds to give us negative 3. That would be x minus 10 and x plus 7. So what we're doing at this point is just solving the quadratic equation, just like we did on our test before fall break. X minus 10, so x equals 10. X plus 7, so x equals negative 7. So now we can draw our sign chart. We need to put these in order. So the negative 7 needs to be on the left. Because if you get them out of order, then when you start testing points, you might end up with the wrong answer. So it is important that we put the numbers on our number line in the correct order. So now we're going to test points. But you notice what happened up here? Negative infinity to negative 6 was positive, and then it switched to negative, and then it switched back to positive. Well, that's always going to be the case with quadratics. They're always going to switch signs in each interval. So if it starts out positive, the next one's going to be negative, and the last one's going to be positive. If it starts out negative, the one in the middle is going to be positive, and the one on the end is going to be negative. They're always going to alternate signs because it's a quadratic, and it kind of goes back to what the graph of a quadratic looks like. So if we were to graph this, we haven't learned how to graph yet, but we would have negative 7 here and 10 here. We would cross the x-axis here and here. So it's going to dip below the x-axis and go back up. So based on the graph of this side would be positive. This in between negative 7 and 10 would be negative. And this over here on this side would be positive. So based on the graph could also look like this. Instead of opening up, the graph could open down. and then this side would be negative, this in the middle would be positive, and then this side over here would be negative. But quadratics are always going to alternate signs. So what we can do, instead of testing 3 points with a quadratic, we really only need to test 1 point. So what point might we test in this case? Maybe I would test -8. Maybe you want to test the middle, 0 or 11. But if we know they're going to alternate because it's a quadratic, we only need to really test one of them. It doesn't matter which one. 0 is actually easier to test than any other number. So I'm going to test 0 in this case. What is 0 minus 10? Positive or negative number? And 0 plus 7, positive or negative? Well, 0 minus 10 is a negative number, so we get a negative. Times 0 plus 7 is a positive number, and a negative times a positive is a negative. So all the numbers between -7 and 10 are negative. And since we've developed this pattern, like, hey, this is a quadratic, the signs are going to alternate. What do we know negative infinity to -7 is going to be? They're all going to be positive. And what about 10 to infinity? Now, this is only true for quadratics. If we do inequalities later on, I might say, hey, remember when we said the signs always alternate? Well, that's not the case anymore. But with quadratics, it will always be the case. The signs will always alternate if we have 2 zeros. Always. So what is our answer? Well, now we're looking at less than or equal to 0. Less than or equal to 0. So we're looking for, when is it negative? And it's negative between -7 and 10. So between -7 and 10, because it's also equal to 0, we're going to have a closed dot. And we're going to connect those dots. So between -7 and 10. So now we're looking at the middle in this case. In inequality notation, -7 less than or equal to x less than or equal to 10. I would hate for you to miss that problem because one of the answers was also -7 and 10, but they used just less than instead of less than or equal to. It definitely has to be equal to in this case. And in interval notation, -7 to 10, and both of those will get brackets because they're both included in the interval. All right, one to go. One to go. Number 3. Number 3. Number 3. Is it equal to 0? No, so that's what we want to do first. We want to make it equal to 0 first, so we can subtract 3x from both sides. So we get negative 3x squared. Negative 3x and negative 14x is negative 17x. Plus 6 is greater than 0. We can factor this. We can also use the quadratic formula. So if you're not sure how to factor this, just use the quadratic formula. You'll get the same answers that I'm going to get. However, I'm going to factor this. And if I want to factor this, I want this x squared to be positive because it's a lot easier to factor when it's positive. And all the other problems that we factored so far, it has been positive. And we can make it positive. We can't divide by anything other than 1. But I want to make it positive, so I'm going to divide by -1. So -3 divided by -1 is positive 3. -17 divided by -1 is positive 17. 6 divided by -1 is -6. We divided by a negative number, so the sign has to switch. And 0 divided by -1 is 0. If we're factoring, since I can't divide by the 3, we're going to need to use the box method this time. Since there's a number from the x squared, we can't just say, hey, what can I multiply to get -6 to add to give me 17? It's not going to work that way. So I taught you guys the box method. So this is one of those problems that we would need to go back to the box because there's a number in front of the x squared. So in the box, we're going to multiply the diagonal together. 3 times -6 is -18. What can we multiply to get negative 18, that adds to give us the middle number, which is positive 17. $18 and negative 1. So those are going to be the numbers that go inside our box. 18x and negative 1x. Now, we could have used the quadratic formula with this, and you would have got the same answers that I'm getting. But all of the problems that we do this week, you will be able to factor. So 3x squared and 18x, we can divide by 3x. Negative 1x and negative x, we can divide by negative 1. 3x squared and negative 1x, we can divide by x. 18x and negative 6, we can divide by 6. So the box method, we did that a lot before fall break. So we get 3x minus 1 times x plus 6 is less than 0. We want to know what would x equal in this case. We would have to add the 1 and divide by the 3. We can work that out if we need to. 3x minus 1 equals 0. Add 1 to both sides. So 3x equals 1. And then divide by 3 on both sides. So we get x equals 1/3. And then we would move the 6 to the other side by subtracting it. So we end up with negative 6. Again, our signs are going to alternate because we are doing a quadratic. So we really only need to test one interval. Make sure we put these in the right order. Negative 6 would go on the left. 1/3 would go on the right. We really only need to test one interval because they are going to alternate. I would like to test 0. And which interval would 0 fall in? 0 would fall in this middle interval for this problem. I know it did the other problem too, but maybe both of my answers end up being positive, which happens sometimes. So 0 wouldn't actually be in the middle. So if we plug 0 in right here, the factored form is a lot easier to figure out if it's positive or negative, especially without a calculator. 3 times 0 minus 1 is a negative number. So we get a negative number times 0 plus 6 is a positive number. And a negative times a positive is negative. So the middle is negative. What do we know about the 2 on the outside? It has to be. I know all 3 examples we did, the 2 on the outside were positive and the 1 on the middle was negative. I realize that. But guess what? That was just coincidence today. It very easily could be the opposite way, where the outsides were negative and the inside is positive. I just picked 3 examples and they all happen to be exactly the same. That's not always going to be the case. It could have been negative, positive, negative. It could have been that way. So now we're ready to figure out our answer. We have just less than. So we are looking for negative, which would be between negative 6 and 1/3. But since it's also not equal to, is only less than, we're going to use open circles this time. It is strictly less than, not equal to. So we're going to use open circles. And if we use open circles, inequality notation, we're going to use just the less than symbol. Negative 6, less than x, less than 1/3. And in interval notation, negative 6 comma 1/3, we're going to use parentheses, not brackets. Parentheses, not brackets.